In the past, we have looked at inductive reasoning, but today, let's look at deductive reasoning. Your learning objectives for this section are to apply basic rules of logic and to compare inductive reasoning and deductive reasoning. Before we get going, just to cover a very basic, logic is the study of reasoning. In the first section, you learned about inductive reasoning, making conclusions based upon patterns. Now, we will learn about deductive reasoning. Here is a definition of deductive reasoning. Deductive reasoning is drawing conclusions from facts. So not patterns, but facts. Conclusions are usually drawn from general statements about something more specific. You'll get a better idea of this as we move on. So, here's an example. Suppose B makes the following statements which are known to be true. That's really important, that the statements that we're about to hear, they're just known to be true. So, if Central High School wins today, they will go to the regional tournament. Central High School won today. So what is the logical conclusion? Again, we see here we have a conditional statement, right? If Central High School wins today, you can basically insert a then here, then they will go to the regional tournament. It's an if-then statement. Central High School won today. So we have two statements, the original conditional statement and then this sentence. Central High School won today. So what is the logical conclusion? The conclusion is Central High School will go to the regional tournament. Back up here at the top. This is an example of deductive reasoning. These are true statements that we can take as facts. What we just did is called the law of detachment. So let's look at example 1 again, but change it into symbolic form to better understand the law of detachment. So P, hypothesis. If Central High School wins today, then Q, conclusion. They will go to the regional tournament. Here's my second statement. Central High School won today. Again, that's just a statement. It's just a fact. Therefore, they will go to the regional tournament. If you notice down here, I have this new symbol for therefore. It's just 3 dots. So the law of detachment looks like this. If P, then Q, and P is true, then Q is true, right? So we're saying if P happens, then Q will happen. And P happened. Therefore, Q happened. That's a very easy way to say that, but I hope you understand. So if P, then Q, and P is true, therefore Q is true. And that's how we write it. P, therefore Q. Next, let's take a look at the law of contrapositive. The following two statements are true. If a student is in geometry, then he or she has passed Algebra 1. Daniel has not passed Algebra 1. So, what can you conclude from these two statements? Again, my two statements are, if a student is in geometry, then he or she has passed Algebra 1. My other statement, Daniel has not passed Algebra 1. So what's my conclusion? Before we answer, let's look at what we're saying. So if P, then Q, if P, then Q, and not Q, right? He has not passed Algebra 1, so not Q. Not Q, if you remember, is the beginning of the contrapositive. Remember contrapositive from last section? We flip the P and the Q, but we also make them negative. So not Q is how we begin a contrapositive. So we can conclude that Daniel is not in geometry. This is the way it works. If P, then Q. If P, then Q, but not Q, therefore we can logically assume that not P, right? Q did not happen, or is not happening, or is not true. Therefore P is not true. That's the law of contrapositive. Lastly, let's look at the law of syllogism. Determine the conclusion from the following true statements. So I have two statements here. If P is late, Mark will be late. If Mark is late, Carl will be late. So, if P is late, what will happen? If P is late, this starts a domino effect or a chain reaction of lateness. Mark will be late and Carl will be late too. So, if P is late, then Carl will be late is the logical conclusion. Each then becomes the next if in a chain of statements. This is called the law of syllogism. So follow me here. So if P then Q and Q and R are true, then P and R is true. It's as if we just kind of skipped the Q, right? If P then Q and then Q then R, then you can just say if P then Q. Again, it's a chain reaction or a domino effect. If P is late, eventually all these things will happen, but Carl will be late. So if P and Q and R are true, then P and R is true.